Hey everybody, welcome to a video about positive and negative, but like not just positive and negative emotions or vibes or whatever, positive and negative and what that means with representations. Okay, so let me show you exactly what I mean. Let's jump right in, okay? Here we have a table, and our first question here is where is the table positive? So I'm just gonna, positive seems like probably an important word in this. Where is the table positive? And another question we have here is where is the table negative? And then our last one we have is there anywhere the table isn't positive or negative? So what is this question asking? Well, questions about this where it's asking where a table or a graph or something is positive or negative is asking about the y values. So I'm only really thinking about the y values in terms of being positive or negative. So, I mean, I don't know. I could just kind of point to where it's positive. Like, where is it positive? Well, that's positive, and that's positive, and that's a positive number. And so, in a sense, like this is kind of like where the table is positive or negative. And really, for my answer, I'm going to kind of think about pointing at the x values. Like the x values are kind of the where we point to, and the y values are what we're looking at. So I would say, oh, this is where the table is positive. These x values. And I do the same thing with negative. Where do we have negative y values? Well, here we have negative y values, and here we have negative y values. And so theoretically, this is where the table is negative. And kind of again, I would sort of point to these x values and say, oh, this is where the table is negative, and that's where the table is negative. Notice I can have positive x values, but I still say the table is negative there because when we ask where the table is positive or negative, we're looking at the y values. And last bit, is there anywhere the table isn't positive or negative? Well, yeah, like that's kind of where it's just zero, right? If the y value is zero, it's not either. And really, we maybe could have even started looking for these points because zero is such a nice, easy number to find there. Like there's a zero and there's a zero. And we sometimes refer to these as like cutoff values, right? So really, it's almost like we're looking for the cutoff values and then the things in between those. It's going to be positive or negative, right? This is how we do it with a table. We're pointing at stuff, we're highlighting stuff. What about with the graph? It's kind of the same idea, right? So here we have a graph. Where is the graph positive? So we're looking for the positive y values. So if I want to find the positive part of the graph, then oh, that's a positive y value, and that's a positive y value, and that's a positive y value, and that's a positive y value. And really, every single part of this graph up until right there, right at that point, is positive because all those points have positive y values. Same thing for negative. Where is the graph negative? Well, that's a negative y value. And all these points along here are also going to be negative y values. Now, physically, what we notice is that the graph is positive where we are above the x-axis. And the graph is negative where we are below the x-axis, right? Look, see like down here, like here's the x-axis right there. And everything above is positive, everything below is negative. What about not positive or not negative? Well, that's going to be where we are on the x-axis. So I could have one last bit, right? So we say not positive or negative is on the x-axis. Okay. Kind of the same idea as with the table. We're pointing at things, we're saying this spot, this spot, this spot. But like that leaves me wanting something more because in math, we often want to try to represent things in different ways. Maybe here we want to use symbols. So let's look at one other thing, and then we'll jump into this idea of using symbols for this stuff, okay? So, as a refresher, we've been talking about y values and x values. It's easy to get mixed up in which one is what we're looking at when and with all that stuff. So, y values are what we are checking. We are looking at y values to answer the question, is it positive or is it negative? Another way of thinking of it, y is what's happening in the table, right? Like the y value is the thing that's saying, hey, I'm positive, I'm negative. The x values are almost more like the where it is happening. So the x values are this is the part of the table that has that thing happening. So it's like we look at the y values, but the x values are kind of our answers. Which gets me thinking, if we're talking about a collection of x values, we're talking about all the x values that are part of something, well, we're actually talking about domain. And I'm going to go out on a limb and say you've probably heard the word domain before, but you've probably forgotten it, right? Which is okay. Domain, right? Domain is the collection of x values that satisfy some requirement in a relation. So this whole time, what we've really been doing is we've been saying, what are the x values that result in positive y values? What are the x values that result in negative y values? We've been finding domains. And we've been pointing at parts of the graph and all that kind of stuff, but that gets a little bit trickier if we have a graph like this. Because what do we notice here? Well, I notice these arrows at the end. And these arrows at the end mean that this graph goes for a very, 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 very long time. Theoretically, it goes forever. And in math, if we're talking about the idea of forever, we're talking about infinity, which is a tricky subject at the best of times, right? And it gets hard to really wrap our heads around. Reminder, the symbol for infinity is this little kind of like sideways 8. Oh, let me do a better job of that. Boom, sideways 8, infinity. That's the infinity symbol. So if we look at this graph here and we highlight where it's positive, so it's positive in this part, positive over here, it's negative in this part, right? And it's equal to 0, it looks like, right on this x-axis again, just like before. But like, I mean, does this graph stop here? It doesn't. It goes forever and ever and ever in that direction. And so I can't highlight forever. And so if I really want to answer this question, I need to use some kind of notation. And that's what I'm going to show you in this next part, how we can actually talk about the parts of a graph that are positive or negative using a more mathematical notation. Okay, let's look at a graph there. So here we have this kind of cool curvy graph, right? Where's the graph positive? Well, I'm going to start by finding the cutoff values again, right? So here it is on the x-axis. That's the point -6, 0. Here it is on the x-axis. That's the point -4, 0. Here it is on the x-axis. That's the point 2, 0. Those are those cutoff values where it's going to be positive or negative kind of in between them. Here it's positive. Here it's positive. Down here it's negative. And here it's negative. Okay, so how do we show this part using a mathematical notation? Well, every x value between -6 and -4 has a positive y value. It's above the x-axis. So what we would say is from -6 is less than x is less than -4, the graph is positive. Like every x value along this part has a positive y value, and that's how you would show this little chunk of the x-axis is with that notation. Same thing for where's the graph negative. Every x value along this part of the graph has a negative y value. And so we would say, oh, from -4 is less than x is less than 2. This is the less than symbol. So we're done, except we're not, because we have this part down here. So what do we put for this? I mean, how far to the left does this go? I mean, it just keeps going and going and going and going forever, all the way to negative infinity. So we're going to do a very similar idea, but we're going to say, well, from negative infinity, everything from that all the way up to -6. Negative infinity is less than x is less than -6. Oh, sorry, I'm doing the negative part. Negative infinity is less than x is less than -6. It's negative in this whole part. So this part right here goes for this part of the graph. And likewise, we can do something for this top part, this far right part of the graph that goes from 2 up forever and ever and ever. We would say, oh, that's just 2 is less than x is less than infinity. It goes on forever. And so we now have these kinds of four little different sections that correspond to these four different parts of the graph, right? One thing to note, a lot of students get mixed up in this part of it where they write negative infinity is less than x is less than negative 6, and they want to write it like this because they want to put the infinity part on the right side. But this is not correct because we kind of go from left to right when we're looking at this. So we go from negative infinity to negative 6. That's why this one does not work, and this one is actually the one that does work. Okay, let me just totally erase this so we didn't think about it. Okay, is there anywhere the graph isn't positive or negative? Yeah, we labeled those points. Those are those points here. So it's like where x is negative 6, negative 6, negative 4, and where x is 2. Those are the points, the x values where the graph is neither positive nor negative. What about for this old table we had before? So before we just pointed at the table and said this is where it's positive or negative. Well, let's do the same idea. So we have these cutoff values. So here's a cutoff value. Here's a cutoff value. I know it's a cutoff value because the y value is 0. And so now I'm saying, well, where is the table positive? Well, it's positive in between these values. So I'm not just going to say 0, 1, 2 now. I'm going to actually use everything from negative 1 to 3. So we would say the table is positive from negative 1 is less than x is less than 3. And for where is the table negative? Well, it kind of is the same idea. So we're looking for the negative y values. So it's everything from this negative 1, and this table theoretically just keeps going. Even though we didn't write it, it just keeps going forever and ever and ever and ever and ever, upwards and downwards. And so now, if we want to find where the table is negative, we would say, oh, well, it stops being negative at negative 1, right? But it's all the way from negative infinity all the way to negative 1. And on the top side, we would say, oh, well, it starts being negative at 3, and it goes all the way from 3 to positive infinity. So even with the table, we can include these ideas of negative and positive infinity, imagining the table keeps going on and on. Hopefully that's good. Hope you feel okay about that. Please ask us questions. We love your questions. They make us happy. Thank you and peace.